Good morning, everyone. In the previous lectures, we have discussed the linear programming problem involving two variable models, and see, the graphical solution method was considered as the most convenient and the easiest way to find the solution of a linear programming problem. However, there are certain problems that is involving when we have more than two variables, or the problem involving large number of constraints. Then it is better to use another popular method which is known as simplex method. So today we will discuss what actually the simplex method and considering one example which is related to the maximization of profit. So the simplest method was actually developed by George Danzig in 1947. It remained one of the most efficient method for solving a large scale linear programming problems. See, the simplex method is used to solve the linear programming problem by using the concepts like slack variables, a tableau and pivot element as a tool to find a optimal solution of an optimization problem. So here we will use the slack variables, tableau and pivot elements. So here the method is through the interactive process. So it is actually an interactive process which actually progressively approaches and ultimately it reaches to the maximum or minimum value of an objective function. So this method produces an optimal solution by satisfying given constraint and produce a maximum or minimum value for the z or the c respectively. So to use the simplex method in the given linear programming problem, it is starting with a standard form where the slack variables can be introduced, and using tableau and pivot element an optimal solution can be reached. And we will discuss here the stepwise procedures, that is to find the optimal solution to a linear programming problem by using the simplex method. Now the first step is that formulate the standard form. So the first step toward the solving linear programming problem by using the simplex method, that is to constitute the standard form which is the baseline format for the all linear programming problem. So of course the standard form is necessary because it creates an ideal starting point for solving the simplex method as efficiently as possible. So the standard form need three requirements. First one is it is the objective function, and the second one is all the linear constraint must be an inequality form, and the third one is that all the variables are non-negative. So here the objective function, that is the standard form of a linear programming problem, require that the objective function is maximization objective. For example, we are going to consider the maximization of profit here. Maximization problem is a type of optimization problem where the goal is to find the maximum value of an objective function subject to certain linear constraint. And in the context of linear programming problem, of course, the maximization problem involves a maximizing linear objective function as well while satisfying all the set of linear constraint. The second one is all the linear constraint must be in inequality form, which means that all the constraint in the linear programming problem must be in linear equalities, or the constraint can be expressed either in inequality or equality form. Both forms are commonly used depending upon the specific problem being modeled. And we all know that all the variable that is non-negative, that is in our problem, the fundamental assumption that the decision variables are non-negative. It means that the value of decision variable cannot be negative. They must be greater than or equal to 0. Now, for example, we are going to introduce our problem in the form of maximization of profit. That is objective function here, it is maximization of profit by taking into account of simply two variable only initially for the simplicity. And in the next lectures we will also consider more than two variable case, for example 3 variable case as well. So here we are considering 2 variable case. So here the objective function, that is maximization of profit, that is z is equal to 4x plus 6y. subjected to the constraint that is minus x plus y which is less than equal to 11, x plus y which is less than equal to 27, and the third constraint that is 2x plus 5y which is less than equal to 90. We have a 3 constraint here, and all the decision variable are here x is greater than equal to 0 and the y is also greater than or equal to 0. Now by using this particular example, the first step we are going to determine the slack variable. So here we are going to convert given inequality constraint into a linear equation by adding the slack variables. So of course, what do you mean by a slack variable? See, slack variables are the additional variable that are actually going to introduce to transform them from the inequality constraint into the equality constraint and transform them into a solvable equalities with one definite answers. So if the model is in the standard form, then the slack variable is always have a plus 1 coefficient, and thus we are adding slack variable to the concerned equation with the coefficient of 1 and add the slack variables in the other equation and give them a 0 coefficient. So in our example, we are introducing non-negative slack variable that is, for example, S1, S2 and S3 and converting given linear programming into a standard form. So that is, it is converting inequality into a equality by adding the slack variable into the given constraint inequality. So we have 3 slack variable here because we have a 3 constraint here. So we are going to consider here 3 slack variable because we have a 3 constraint here. This is the original problem. Now we are going to convert here the first constraint that is minus x plus y. See, I am introducing the slack variable 1 that is S1 by putting the coefficient is equal to 1 plus 0 S2 plus 0 S3, that is coefficient of S2 and S3 are 0, and converting this inequality sign into the equality which is equal to 11. Similarly, the second constraint that is x plus y plus, see here 0 S1 plus the coefficient of S2 in the constraint number 2, it will be 1. And plus 0 S3 and converting this inequality sign into the equality sign, so it will become equal to 27. Similarly, the third constraint that is 2x plus 5y plus 0 S1 plus 0 S2, and here we are adding the coefficient with the 1 is the coefficient that is S3 which is equal to, that is less than equal to, I am going to convert in the equality sign that is equal to 90. Similarly, we are going to consider the objective function that is maximization of z which is equal to 4x plus 6y. I am going to take this 4x plus 6y into the left side of the equation. So it will become, see, minus 4x minus 6y plus, here also we are going to consider that particular slack variable but putting the coefficient as 0. So 0 S1 plus 0 S2 plus 0 S3 plus z also here. So which is equal to 0. Now we are converted in the standard form. Now after this, introducing the slack variables, we are going to convert inequality into the equality constraint which was set up a tableau that represent linear programming model and check for the optimality. So the next step is to set up the Simplex tableau which is used to perform raw operation on the linear programming model as well as to check the solution for the optimality. So the tableau is actually organized in such a way that the coefficient of the decision variable and slack variables along with the coefficient of the objective function we are going to write in the tabular form. So here we are going to consider the coefficient of the corresponding to the linear constraint variable and the coefficient of the objective function in a tabular form. So I am putting here the table, that is, see this particular our original problem which we are converted in the standard form, now introducing the table here. See, considering the variable x and y here, then we have 3 slack variable introduced that is S1, S2 and S3. Then B is denoting for the constant constraint, then basic variable that is S1, S2 and S3. Then we are putting the coefficient of all these things into this particular given table. So here the coefficient of x is minus 1, 1, the coefficient of S1 is equal to 1, coefficient of S2 and S3 which is equal to 0 and 0. then we are putting the b here, it is 11. Then the coefficient of the second constraint, that is 1, 1, 0, 1, 0, which I am putting here, and the 27 we are putting here in this particular column. The third constraint we are putting here, that is 2, 5, 0, 0 and 1, which is equal to 90. So coefficient we are represented in the table, and the coefficients of the objective function we are considering in the last row, that is minus 4, minus 6, 0, 0, 0, that is coefficient of S1, S2 and S3. Now we are formulated the simplex table. Now the next step is check the optimality. So after setting up the table for the given linear programming problem, the next step is to check the given solution is optimal or not. How we are going to consider or going to check the optimality? So to check whether the given solution is optimal or not, by using this particular given tableau, where we will look at, all the entries in the bottom row of the tableau are negative or not. And all the entries in the bottom row of the tableau are negative, or one of the element is negative, then we can say that it is not optimal. That is, if all the values in the last row in the given tableau or objective row, that is the coefficient are non-negative, which means that they must contain the value is greater than or equal to 0, especially in the last row. So then we can say that the solution is optimal. But the value of the objective row is less than 0 or negative, it means that the solution has not reached its optimal value. It means that our current solution is to be improved, and the simplex method proceed to pivot towards a better solution. So by considering our table, let us see here the given table. The last row, we have two negative values exist in the bottom row, indicating that the solution is not optimal. So in order to make an optimal solution, we need all the positive value or it is equal to 0. But here we have two negative values exist. So in the bottom row, so here it is not optimal. Then if it is not optimal, then the next step is to identify pivot variable or the element through interactive process to create a particular new table. Now we are going to identify here, see the pivoting of process or pivoting process we are going to undertaken here. See here, if the current solution is not optimal, then we want to improve the current solution. How we are going to improve? Through the process of pivoting. What is actually mean by the pivoting? Pivoting is an interactive process to form an improved solution. What is the improved solution? Is one that is the larger z value than the current value, which is negative now. So the improving the current solution, we bring the new basic variable into the solution. We can call this is an entering variable. When the one variable is entering into the system, one of the current basic variable must leave. Otherwise, we would have too many variables for the basic solution. So we are call this particular variable is departing variable. One variable is entering and another variable is departing. So what actually the entering variable means? See, the entering variable corresponding to the smallest or most negative entry in the bottom row of the tableau. So in the given table, we want to identify the smallest non-negative value. And by picking up the smallest negative value in the bottom row, that column is marked as a pivot column. Then to find the departing variable, see, we can divide the B column, that means the constant column of the linear constraint, by considering the pivot column. We are going to divide the B values by using the pivot column, which is generally known as it is the test ratio. Then, departing variable. What is the departing variable? Corresponding to the small non-negative ratio in the column vector. So here the pivoting is actually going to take. So here the pivoting of the row can be take place. So for the value in this particular column, divide the far right column by each value to find out the test ratio. And the value with the smallest non-negative test ratio is generally known as it is pivot column. Then after that, the intersection of the row with the smallest non-negative and the column with the smallest negative value in the bottom row will become pivot element or it is pivot variable. So the coefficient at the intersection of the pivot row and pivot column that is marked as a pivot element. So we will do all this process by using the example so that it will be more clear. So in our example, see from the bottom row of the table, the new coefficient of the objective function, see it is -4 and -6. Here it is smallest negative value for the bottom row which is equal to -6. So we are considering this is the pivot column. So we are highlighting here it is the pivot column. Once the pivot column is fixed, the next step is to find the pivot row, which can be found by dividing the B value of the linear constraint by their corresponding value from the pivot column. So how it will be? See, we are going to consider this is the B value. We are going to divide each element here by using the pivot column. So it is 11 by, which is generally known as it is test ratio. So it will become 11 by 1, which is equal to 11. Then 27 divided by 1, which is equal to 27. Then 90 divided by 5, which is equal to 18. So this is the test ratios. Now after finding the test ratio, out of these particular values, that is 11, 27 and 18, select the smallest non-negative value here. And here it is smallest one is, it is 11. So this particular row, that is the first row, will be considered as the pivot row. So I am highlighting here the pivot row by using the dark color. So this is the pivot row and this is the pivot column. So after that we want to find out, the intersection of the pivot column and the pivot row that is marked as, pivot element. So here it is marking the element that is 1 is the pivot element. So after marking the pivot element, now we are going to restructure the entire table, especially by using the each element or each value of the given column. So here first we are going to consider, that is, see, by considering the pivot element, that is pivot row, we are going to replace by using a new coefficient or new values. How we will get the new pivot row elements? We are going to multiply each element by using the reciprocal of pivot element. So the reciprocal of pivot element will be 1 by 1. So here the first element is -1. We are going to multiply with the reciprocal of pivot element, that is 1 by 1. So it will become -1 into 1 by 1, which will become -1. Now second one, that is 1 into 1 by 1, that is reciprocal of the pivot element, which is equal to 1. Then the third element, that is 1 divided by 1 by 1, which is equal to 1. Then here the fourth one, it is 0 into 1 by 1, which is equal to 0. Again the 0 into 1 by 1, which is equal to 0. Then the B column, that is 11 into 1 by 1, which is equal to 11. Now we are going to replace the each values in the pivot row by using the new values, that is -1, 1, 1, 0, 0, 11. So here I am replaced. So in this particular table I have replaced the actual values in the pivot row. So this is the new values. Now after finding the new pivot row, we are going to replace the second, third and the objective rows. So here considering the second row, so here the second row values, that is 1, 1, 0, 1, 0, 27, we are going to replace. See how we can find out the new value, so which is equal to the old value minus corresponding value in the pivot column into new value in the pivot row. So here the old value in the second row, here second row we are going to consider, that is old value was 1 minus the corresponding value in the pivot column. So here the pivot column is this one, here the corresponding value which is equal to 1, so -1 into new value in the pivot row, that is new value in the pivot row is this one. So here corresponding to 1, new value is -1. So here we are putting 1 minus 1 into -1, which is equal to 2. Similarly, the second value, that is 1 minus the corresponding value in the pivot column, that is also equal to 1. Then new value multiplied, that is 1. So it is 1 minus 1 into 1, which is equal to 0. Similarly, the third element, that is 0 minus 1 into 1, that is new value, which is equal to -1. Then 1 minus 1 into new value, which is equal to 0, which is equal to 1. Then here 0 minus 1 into 0, which is equal to 0. then 27 minus 1 into 11, which is equal to 16. So now this second row we are going to replace with these new values. So it will become 2, 0, minus 1, 1, 0 and 16. Similarly, the third row, each value we are going to replace with a new value by using the same formula. So the third row, here new values of third row will be old value minus corresponding value in the pivot column. So here it will be 5 into new value in the pivot row. So here the old value it is 2, 2 minus 5 into new value which is equal to minus 1. So it will be 7. Similarly, 5 minus corresponding value in the pivot column, that is equal to 5 into new value which is equal to 1, which is equal to 0. Similarly, the third element, that is 0 minus 5 into new value which is equal to 1, so it is minus 5. Then 0 minus 5 into new value which is equal to 0, which is equal to again come out with 0. Then 1 minus 5 with the new value, that is 0, which is equal to 1. And similarly, the last element, that is 90 minus 5 and the new value which is equal to 11, so which is 35. So this third row we are going to replace by each element which we are calculated here. So it will become 7, 0, minus 5, 0, 1, 35. Now the last row, that is row which is related to the, it is objective coefficient. So here we have minus 4, minus 6, 0, 0, 0, 0. So here again we are using the same formula, that is old value. So it is minus 4 minus, then corresponding value in the pivot column, that is minus 6. So minus 6 into new value in the pivot row which is equal to minus 1. So if you go for solving it, then it is minus 10. Similarly, the second value, that is minus 6 minus minus 6 into 1 which is equal to 0. 0 minus minus 6 into 1 which is equal to 6. Then 0 minus minus 6 into 0 which is equal to 0. Then again 0 minus 6 minus minus 6 into 0 which is equal to 0. Then 0 minus minus 6 into 11 which is equal to plus 66. Okay. Now the last objective row we are going to replace with the new calculated value here. So it will become minus 10, 0, 6, 0, 0 and 66. See, once all the elements of new table are calculated, it says now we are replacing the departing variable. What is the departing variable here? Departing variable here, it is pivot column variable, that is why we are going to depart, and with entering variable. So what is going to enter? That is pivot variable. So here entering variable, here it is y, that is pivot column, and they replace with the pivot row variable, that is S1 with y. So it will become, now the replacement is going on with the entering variable and the replacing variable. Entering variable is here the column variable, that is y, and the replacing variable it is pivot row variable which is equal to S1. So I am writing here S1 is replaced with y. So after doing all the exercise, now the new table is ready for checking the optimality check. So to check whether given solution is optimal or not, see again we want to look at if all values in the bottom row are positive or equal to 0. See here, all the entries are positive, then we can say that the solution is optimal. But again we have a minus 10, a one negative value exists in the bottom row, which indicating that the solution is again it is not optimal. See, if it is not optimal, then the next step again go for the process of pivoting by identifying pivot column, pivot row and the pivot element through the interactive process to create a new table. So we are going to create the new table by identifying pivot column, pivot row and the pivot element. So here we have the least value, that is most negative entry in the bottom row. Here it is again only one value which is minus 10. So we are going to pick up the small negative value in the bottom row which is equal to minus 10, which is considered as the pivot column. So this is the column marked as pivot. So I am highlighting here. Then we find the pivot row. to calculate the test ratio, for that we are going to divide the B values with corresponding values in the pivot column. So it will be test ratio. So 11 divided by -1, which is equal to -11, 16 divided by 2, which is equal to 8, and 35 divided by 7, which is equal to 5. So here we are going to consider, see, departing variable which is the smallest non-negative ratio. So this will be departing variable and this is the pivot row. So now here the departing variable corresponding to the small negative non-negative ratio. So here the smallest non-negative ratio, it is 5. It is negative, it is plus, but it is the smallest non-negative ratio in the test ratio. So we are going to consider this particular value which is in the third row. So the third row will now become the pivot row. So after identifying pivot column and pivot row, we are going to identify the pivot element. So here the intersection of the pivot column and the pivot row, that is identified as a pivot element. After identifying the pivot element, now we are going to restructure the table again. See, first we are going to replace pivot row by considering the formula, that is multiplying each element by using reciprocal of pivot element. So reciprocal of pivot element, which is equal to 1 by 7. This is the pivot element. So we are going to consider the reciprocal, which is 1 by 7. So 7 into 1 by 7, which is equal to 1. 0 into 1 by 7, which is equal to 0. Minus 5 into 1 by 7, which is equal to minus 5 by 7. Then 0 into 1 by 7, which is equal to 0. Then 1 into 1 by 7, which is equal to 1 by 7. 35 into 1 by 7, which is equal to 5. So this is the new element. We are going to replace this pivot row by using new calculated element here. So now I am going to replace all these values with this. So it will become 1, 0, minus 5 by 7, 0, 1 by 7, 5. Okay. Now again we are going to consider the first row and we are going to replace these values by using new value. What is the new value? We are going to use the equation, that is old value minus corresponding value in the pivot column into new value in the pivot row. So here the old value, which is equal to minus 1. What is the corresponding value in the pivot column? Which is also equal to minus 1. Then into new value in the pivot row, which is equal to 1. So here see, it is minus 1 minus minus 1 into new value, which is equal to 1, which is equal to 0. Similarly, second value, that is 1 minus minus 1 into 0, which is equal to 1. Then 1 minus minus 1 into minus 5 by 7, which is equal to 2 by 7. 0 minus minus 1 into 0, which is equal to 0. Then 0 minus minus 1 into 1 by 7, which is equal to 1 by 7. Then the last one, that is 11 minus minus 1 into 5, which is equal to 16. So all the old values in the first row we are going to replace with the new calculated value. So it will become 0, 1, 2 by 7, 0, 1 by 7, 16. Okay. Now after that again we are going to find the new value for the second row. So here we are using the same formula, that is old value minus corresponding value in the pivot column into new value in the pivot row. So here the old value, which is equal to 2, minus the corresponding value in the pivot column, that is also 2, because this is the pivot column. Then into new value in the pivot row, which is equal to 1. So 2 minus 2 into 1, which is equal to 0. Similarly, for the second, that is 0 minus 2 into 0, which is 0. Then third one, minus 1 minus 2 into minus 5 by 7, which is equal to 3 by 7. 1 minus 2 into 0, which is equal to 1. Then 0 minus 2 into 1 by 7, which is equal to 2 by 7. Then the last one, that is 16 minus 2 into the new value in the pivot row, which is equal to 5, which is equal to 6. So the second row I am going to replace with the new calculated value. So it will become 0, 0, 3 by 7, 1, minus 2 by 7, 6. Now we have one more row, which is the objective row, which we want to replace. So this is the objective row here, minus 10, 0, 6, 0, 0, 66. We are going to replace with the new value by using the same formula. So here it is, old value which is equal to minus 10, then minus corresponding value in the pivot column, that is also minus 10, into new value in the pivot row which is equal to 1. So which is equal to 0 again. Then the second one, 0 minus minus 10 into 0 which is equal to 0. Then 6 minus minus 10 into minus 5 by 7 which is equal to minus 8 by 7. Then again 0 minus minus 10 into 0 which is equal to 0. Then 0 minus minus 10 into 1 by 7 which is equal to 10 by 7. Then the last one, 66 minus minus 10 into 5 which is equal to 116. Again we are going to replace this particular row by using new calculated value. So it will become 0, 0, minus 8 by 7, 0, 10, 10 by 7, then 116. See, once all the elements of new table are calculated, now we are replacing the departing variable. So here the departing variable with the entering variable. What is the entering variable here? That is the pivot column will be the entering variable, that is x will be entering. We are going to replace with the pivot row. So pivot row is this one. So S3 will be replaced with this particular variable x. So here earlier it was S3. Now we are replaced with x. Okay. Now again the table is ready for the optimality check. See whether we want to check the given solution is optimal or not. How we will look at? See, if all the values in the bottom row are positive or equal to 0, then we can say that we have an optimal solution. But see here, we have one negative value exists in the bottom row, indicating that this solution is not optimal. If this is not an optimal, then the next step, whatever we did, we are going to conduct the process of pivoting by identifying pivot column, pivot row and the pivot element. Then again we are going to replace each and every values here. So here of course minus 8 by 7 is exist here. This 8 by 7 now become it is pivot column. So here after identifying the pivot column, I am highlighting here. The next one is going to calculate the test ratio. How we will calculate test ratio? It is 16 divided by corresponding value in the pivot column. So it is 16 divided by 2 by 7 which is equal to 56. 6 divided by 3 by 7 which is equal to 14. 5 divided by minus 5 by 7 which is equal to minus 7. So out of this, the lowest positive value which is equal to 14. So which is on the second row, that is S2 row. So I am going to consider this particular row is a pivot row. So which is highlighted with the red color. So we have a pivot column and the pivot row both are intersecting here, that is 3 by 7 which is considered as the pivot element. Now after considering the pivot element, now we are going to replace the each and every value in the pivot row by using the reciprocal of 3 by 7. That is reciprocal of 3 by 7 which will become 7 by 3. So here we are going to multiply each element by using the reciprocal of the pivot element, that is 7 by 3. So it is 0 into 7 by 3 which is equal to 0. 0 into 7 by 3 which is equal to 0. 3 by 7 into 7 by 3 which is equal to 1. Then 1 into 7 by 3 which is equal to 7 by 3. Then minus 2 by 7 into 7 by 3 which is equal to minus 2 by 3. Then the last one, that is 6 into 7 by 3 which is equal to 14. Now we are going to replace the each and every values in the pivot row by using the new value. So it will become 0, 0, 1, 7 by 3, minus 2 by 3 and 14. See, after finding the new values for the pivot row, we are going to replace the old values in the first row, second row and the objective row again. So here the first row, old element, that is 0. So here we are going to consider again the calculating new value. So old value, that is equal to 0, that is 0 minus it is corresponding value in pivot column, that is 2 by 7 into new value which is equal to 0. So which is again come out with a 0. Then the second one, that is 1 minus 2 by 7 into 0 which is equal to 1. 2 by 7 minus 2 by 7 into 1 which is equal to 0. then 0 minus 2 by 7 into 7 by 3, which is equal to 2 by 3. Then 1 by 7 minus 2 by 7 into minus 2 by 3, which is equal to 1 by 3. Then 16 minus 2 by 7 into 14, which is equal to 12. So this first row, now we are going to replace with the new calculated value. So it will become 0, 1, 0, minus 2 by 3, then 1 by 3 and 12. Similarly, we are going to calculate a new value for the third row. Third row, so by using the same formula, that is old value minus corresponding value in the pivot column into new value in the pivot row. So the first value, which is 1 minus 5 by 7 into new value, which is equal to 0, which is equal to 1. Similarly, second one, 0 minus 5 by 7 into 0, which is again 0. Then the third one, minus 5 by 7 minus 5 by 7 into 1, which is again come out with 0. Then 0 minus 5 by 7 into 7 by 3, which is equal to 5 by 3. Then 1 by 7 minus 5 by 7 into minus 2 by 3, which is equal to minus 1 by 3. Then 5 minus 5 by 7 into 14, which is equal to 15. So the old values now we are going to replace with the new calculated value. So it will become C 1, 0, 0, 5 by 3, minus 1 by 3 and 15. Now the last row, that is the objective row, we are going to consider. So again, by using the same formula, that is old value minus corresponding value in the pivot column into new value in the pivot row. So here the first value is 0 minus 8 by 7 into 0. This is the new value in the pivot row. So it will become 0. Similarly, the second one, that is 0 minus 8 by 7 into 0, which is again come out with a 0. Then minus 8 by 7 minus 8 by 7 into 1. It will become again 0. Then 0 minus 8 by 7 into 7 by 3, which is equal to 8 by 3. See, next one is 10 by 7 minus 8 by 7 into minus 2 by 3, which is equal to 2 by 3. Then the last one, that is 116 minus 8 by 7 into 14, which is equal to 132. So this now the new old elements, now we are going to replace with the new calculated value. So here it will become 0, 0, 0, 3 by 8, 2 by 3 and 132. See, once all the elements of the new table are calculated, now you are replacing the departing variable with entering variable. So here what is the departing variable? The objective row, here the pivot column will become the entering variable, that is S1 is going to enter, and the S2, the earlier here it was S2, that is going to depart. So now we are replacing, that is S2 with S1. So S2, which is departing variable here, that is replaced with the entering variable, that is S1 here. So after this, the table is ready for the optimality check. So if given the table, if all values in the bottom row are positive or equal to 0, then we can have a optimal solution. So of course, here the new values in the bottom row are positive or it is equal to 0. So indicating that this is the optimal solution. So ultimately, we reached an optimal solution through the interactive process. So here all the entries are the positive. So we can say that it is an optimal solution, or it may be 0. Then also we are considering it is we don't want any negative value here. So here there is no negative value. We reached the optimal solution. So optimal solution here, see, there is no negative value elements in the bottom row. It is considered as an optimal solution. So here the value of x, y and s1 are given. Here the variable x is equal to, it is 15, and variable y is equal to 12, and the variable s1 is equal to 14. So x, y and s1 variable are given here, and s2 is considered as the 0 and s3 is also considered as the 0. So variable x is equal to 15 here, and variable y is equal to 12 here, and s1 is equal to 14, s2, s3 are considered as the 0. So this is the process of solving the linear programming problem. By using the simplex method, we can calculate the objective function, that is 4x plus 6y. This was the objective function, that is maximization of profit, that is 4x plus 6y. By substituting the value of x is equal to 15 and the value of y is equal to 12 on the objective function, then it is equal to 132. Let us check, here is also equal to 132. So 132 is equal to 132. We can say that the optimal solution is reached. The function, the given linear programming problem is reached the optimal solution. So through this particular interactive process, we can reach the optimal solution. I hope it was clear to you. In the next lecture, we will consider the solution of linear programming problem by taking 3 variable model. So we'll see in the next lecture. Thank you.